everyone. So today we're going to talk about SOC L1 and L2 triage, basically. Okay, we're going to focus on the practical attack playbook. Okay, this session is going to be very important, and even if you just watch this session, you're going to learn a lot, because I'm going to show you how it's done in the real world. We're going to learn together how it's the like, for example, there is an attack, what you will do, what is your next step. Okay, step by step. We call this playbook actually. Okay, and triage means that's what it means. Basically, it focuses on what attacks actually look like, what alerts fire, how to check, what to check, how attackers behave. So let's start with phishing. Okay, this is very important because most of the hackers, okay, they get initial access to an organization or a company or a PC, any system, through mostly through phishing. Because phishing, they will send you a phishing email, and you're going to click a link. The victim is going to click the phishing link, put their data, or they're going to download an attachment. Okay, like this. So a phishing email, a hacker will send you a phishing email. If you want to learn more about phishing, you should review my phishing video on this course. And then a user will open the attachment or link. Okay, that's what the user will do, right? Then once they open it, it's going to run PowerShell, right? Once they open the attachment or link, it's going to run PowerShell. Okay, it's going to execute PowerShell or MSHTA executes, and on the background, then you will see a payload downloaded. Okay, once the payload is downloaded, they can either steal credentials or move lateral movement. Okay, so what you usually see in SOC is first ML alerts. Like if you, for example, you have set up an monitoring system like Splunk or another system. Okay, first it's going to check, it's going to give you an alert, right? Suspicious attachment, and you like an alert that you've received a suspicious attachment, and then the next step is the victim is going to click a link or phishing. Okay, then a macro, or if there is a document, even if you click, like it might look like a Word document, a normal document like docs or PDF, right? But when you click it, you're going to open another PowerShell or CMD, any other executable like PowerShell. Okay, this is what we call macro, actually, macro enabled document. There is a way to do it here. I don't actually remember how it was, but you can enable macro here. I think we need to check here what is so I can show you an example of macro enabled document. These are very dangerous. Like, they look like authentic, like this one. This is how you can identify it. See, it's a Microsoft Office file, okay, containing embedded Visual Basic of application code, which automates repetitive tasks. Okay, usually it's going to be docm or xlsm. Okay, these are the formats of macro enabled. Macros can be used by attackers for malicious purposes, such as installing malware. Microsoft typically blocks them by default, requiring users to enable component. Yeah, so usually it's blocked. Okay, it will ask you to enable content. Okay, yeah, so yeah, so we can, yeah, that's the thing with macros. Okay, yeah, so that's the idea. We should be careful of it will look like this, but it's a macro. Then you run it, then some other partial, it will open another partial executable. Okay, that's why HackerX love this so much. Identity alert, impossible travel, MFA, fatigue. Okay. So as an L1, SOC L1, we focus on, did the user click the link? Did the file execute? Was PowerShell spawned? Any outbound connection? Credential entered? So these are the questions that we need to think of as a level 1 when we are doing triage. Okay, so these are the questions that we need to ask. High risk indicators are office spawning process. Okay, this is a risk. Office spawning process means you open Excel, but at the same time it opens cmd.exe. Okay, you open Word, it opens PowerShell.exe. This is extremely suspicious. We have to be careful with this one. So also we need to have a look on for PowerShell -inc command. Okay, this command usually it is for malware staging. Okay, so attackers abuse trusted binaries like mshta.exe. Okay, you can run this one, so you can run this one here and see what it will open. Okay, we have run DLL 332 regv ws script certutil. So the attackers will usually abuse this trusted binaries. Okay, L2 investigation, hunt for persistent credential dumping. Yeah, when you are what L2 will do is actually check for persistence, credential dumping. Credential dumping means they will take all the credentials from memory or the PC, and they're just going to get it in their PC. New scheduled task, like we've talked about this also, attacker will the L2 will look for any scheduled task, because this can be used by hackers for persistence. They will check the registry run keys, they will check for beaconing traffic, they will check for additional host impacted, all this stuff. L2 is going to check this stuff. Okay, the most common is actually credential attacks. Okay, we have something called password spraying. Okay, this tries one common password against many users. Okay, because usually companies or organizations, they're going to use the same passwords for many users. Okay, different users, like 1 to 3 or something like that, right? So what the hacker will do is, like, for example, he will take all the list of different users, and he's going to try the same password for all of them. If let's say he will identify first the first one password, then he will try for 500 users. Okay, he will try this one against 500 users, one attempt each. Okay, if he does like this, he avoids account lockout. Okay, account lockout is when it will block you, right? When you try different wrong passwords, usually you get blocked, right? But if you try only one time for different users, it's not going to lock you, because you're trying different users. You're resetting the time, right? So SOC indicator, we have logs. Here we have many usernames. We have to just check the logs also. If you see many usernames, the same source IP, same password pattern, authentication failure, right? We have event IDs 4625, failed login. We have to look for failed login like this one, and successful login like this. This is for Kerberos authentication, this is for Kerberos pre-auth failure. L1 L1 triage. Okay, check the L1, for example, is just good. These are the L1 try for L1 they should focus on the same source country, VPN, proxy, success after failure. This is a strong indicator that someone is trying to do brute force attack, right? Because multiple failures and then suddenly successful login, that means he has already got the initial access. Service account MFA triggered. Escalate if successful authentication. We have to escalate it to L2. If admin accounts is targeted, multiple systems involved. Escalate if successful authentication, admin account targeted, multiple system involved. Brute force differences, many password against one user, few users. Indicators, 100 failures in one account. Okay. Yeah. So this is what we call by brute force attack. L2 focus is just going to focus on success events. Okay, they don't care about the failures. Okay, this is L1. But if the L1 found a list of failures, but suddenly when one successful login, that means there is the hacker already got in, he got access. So they will escalate to L2, then L2. That's you will focus on success events. Okay, and after success events, after he got access, the next step is lateral movement, right? Moving from one PC to another after login. So we have new MFA registrations, mailbox access, all this stuff. Yes, a business email compromise, for example, is a huge financial impact, usually no malware. Okay, for business email compromise, this is another attack, common attack. First, obviously, they're going to do credential phishing, and then credential phishing basically it's like they will send you a link. They will tell you to put your information like cards or something, and if user is not smart enough, he will just put the credentials and users there, credential or information. It's going to, all that is going to reach the attacker. Mailbox compromise. We have mailbox compromise here. Yeah, once you get the credentials, you get the mailbox compromise. Mailbox compromise is basically like this. Like, let's say I received an email here. Many spam emails here. Okay. Like, oh, they're telling me to, since your account has been inactive for extended period, please update your account information properly to ensure uninterrupted service. I receive a lot of emails like this, okay, and they give me a link to update. Right now, if I click this link, okay, it's going to take me to some place where I'm supposed to fill account information, right? Account information, and then they're going to going to get compromise the mailbox, and they might create some rule in the inbox, for example, like internal impersonation, invoice payment fraud, or they can do many things. User logs in from Saudi Arabia, then Germany 5 minutes later. So this is an impossible travel. This is impossible travel. You got me? So you see, you cannot be in two countries at the same time, just 5 minutes difference. So this is why we call it. This is an indicator that tells you this attack. Also, you can check the inbox rules. when if you see move all invoices to RSS folder, for example, or forward mail externally, they can do all this stuff, right? A hacker can do all of this. So they can create a rule. You can create a rule from cPanel or from here itself. Like OAuth abuse basically is user grants permission to malicious application token theft app. Okay, so L1 he checks if multi-factor authentication is enabled, and he checks if there are any mail forwarding rules. Like he checks if OAuth is grants. Login anomalies, new devices. L2 he determines that the access, finance discussion, external forwarding, internal phishing link sent. Then we have malware or rat infection, common after phishing, basically. Yeah, after phishing, the next step is malware, right? They have to attacker wants persistence. Like he doesn't just want to hack your PC and get access to your PC. That's not the end of it. That's just the initial access, right? Then he needs to make sure to stay there, like forever, right? That's the goal of an attacker. How can he do that? Right now he just got an initial access, but let's say you shut down the PC or you do something. Now he doesn't have access. Okay, he needs to find a way so he can stay there for a long time. He can use schedule task or run registry key, startup folders, anything. Thing. Once he establishes persistence, he checks for remote access. Credential theft. This is the first thing they do actually. There's a command called #dump. Okay, once they get access, they will check what most of the credentials are stored in memory. Okay, for this PC, for example, if I got access to a domain controller, I will have a lot of credentials. Okay, so I will just take all the credentials using, there's a tool called Mimikatz or stuff like that. Then once I got access, I will try to move around. Okay, now that I got access to this or to the domain controller, that's not it. I have to move around. I have to move from one PC to another. Just keep moving. So common malware behaviors is beaconing. Okay, beaconing is a periodic outbound traffic. Okay, every 60 seconds, the infected PC sends outbound traffic every 60 seconds. Okay, and suspicious IP or a domain, a rare domain. Okay, that's how you can identify beaconing. You can use a tool called Wireshark. Okay, let's say we have Wireshark here. Okay, this is an example of traffic. You can go to statistics and check the conversation. That's what we care about, right? We check the IPv4, and I can see that data is sent from one point to another, okay, periodically with a specific. That's called beaconing. For this, actually, I have already a YouTube channel. I have already mentioned, talked detail about this in my previous, course. Like if you go back to my Red Team course here, I have talked in detail about C2 command and control. Okay, you will understand beaconing here. Okay, so you will understand beaconing. Also, you will understand. There's one more video here where I talk about lateral movement, persistent, and parallel escalation. But I suggest you go through this one because I talked about how C2 beaconing and also persistence post-exploitation are also included in this video. This is a very important video. Have a look at it, and if you want to also understand more about Active Directory attacks, this is also important. Password spray, brute force attack, all this, how they are performed from a red team, from a hacker point of view. You should go through it as well. Persistence, just like I told you, these are the ways of doing it. Schedule task, this is a command to create a schedule task. This is a registry run key and service installation. We focus on this one. And high signal indicators, we have temporary execution. Malware loves temp file folders. Okay, we have to look for a file that is executed from temp. Okay, yeah, unsigned executable, especially random names, and user directory temp path. So L1 workflow is basically hash reputation. They check the hash reputation, and they can use virus total, get the hash. Also, I talked about how to get the hash from a file or a link on the previous video. And process tree, also this we've talked about it. Check the process tree, like yeah, persistence, check for network callbacks. Yeah, check if there are any outbound traffics, anything that's going outside of your network from a PC. L2 workflow, the initial vector, C2 infrastructure, lateral data exfiltration, all this stuff. So PowerShell attacks are massively abused. Okay, why attacker love PowerShell? Because they are built into Windows. They are powerful, trusted, fileless capability. Fileless means it can run on the memory. Okay, like common malicious command you should look out for are PowerShell-enc encoded, download payload. This is used to download payload, and this is used for hidden window. This is extremely suspicious. I told you already. If you see PowerShell spawned from on Word or Chrome or Outlook or whatever, then it's an issue. Focus on the process creation and script blocking logging. So L1, he is checks if it's encoded, network traffic, parent, user, admin content. L2, payload downloaded. This is their focus basically. Ransomware is also another thing. Ransomware is actually very dangerous because it will encrypt all your data, and they will the attacker will ask for a ransom in order to give you the key or to decrypt it for you. So if you're smart, SOC analyst, you're going to back up everything, okay, initially, and yeah, and you have to look for ransomware. So initial access, then credential theft, then lateral movement, then domain admin, then data exfiltration, then encryption. This is the steps. Before encrypting your data, they will usually exfiltrate. They will usually actually exfiltrate it, because they will take the copy of the data before they encrypt your data. So that's the idea. So early warning sign, they check. You have to check also Defender. Like they will disable Defender because they will delete the shadow copy. They will use PSExec, often lateral deployment. This is a tool that's used to move laterally. Mass SMB activity, it's encryption spreading. So L1, immediate action. Your job is actually to escalate, isolate the host, notify incident response, preserve evidence. Determine patient 0, initial access, privilege escalation, filtration, spread scope. That's the idea. Credential dumping is very common before ransomware. Okay, yeah, this is the tool that I told you about, Mimikatz. Again, you can learn more about this stuff in my Red Team course, because I talk about all this stuff in details. Okay, like all these advanced concepts like Mimikatz, you can find it here in Active Directory attacks. Actually, yeah. LSAS access, attackers dump memory from LSAS. Yeah, this is an indicator. Suspicious command like this, EDR alert, usually credential that LSAS handles memory. L1 action, user context and remote session. L2 focus, determine which credentials stolen, privilege level, Kerberos abuse. Yeah, Kerberos. Again, Kerberos is another concept that you will learn after watching this video. Okay, so at the very least, you should watch this video and this video, this two, 12 and 13. Very powerful videos. Okay, one of the best in my channel actually. I explain everything in depth and I show you practically, not just theory. and lateral movement. We have critical attack phase. Yeah, this is just moving from one place. These are the tools that we need to memorize. Mid-RAM is partial remote. It's a remote command, WMI, SMB, file transfer, PSExec for remote execution, RDP. All these tools are techniques what the attacker uses to move from one PC to another. This after for lateral movement. Okay. So you have to look for remote logins. Login type 10. Okay, if it's 10, that means it's RDP. Okay. Login type you can find it on event viewer. I have showed you in the previous session as well. So yeah, event viewer, we have it here on the, for example here, if you filter by the, or you don't need to filter, I just want to show you where you can see the login type. So you can find login type here. Let's just first see 4624 or 46, yeah, here this is logged in. Okay, we check the this is login type. It says 5 here, but it should be 10. If it's 10, it's RTP. Admin shares, we have this shares that can be exploited. Remote service creation, the shares actually can be exploited. L1 check the source code, expected admin activity, time of the day, multiple hosts, all this information. L2 they map basically, tracks attacker's movement, like they follow what attacker actually did. Check, he got access to host A, then to get access to host B, from host B he got access to the domain controller. Okay, that exfiltration often happens before ransomware. Okay, yeah, so just like I told you, they take the data before encrypting your data. Okay, they take a copy of the data, so that's why you have to look for anything that's going outside of your network. Common exfiltration methods, we have cloud storage, mega uploads basically, or HTTPS. This is uploads rare domain. You have to look for a rare domain. rclone, command link, FTP. Archive creation, we have this one. You have to look for archive, because archive usually the data is going to be too much, right? They cannot just upload it to the cloud or try to exfiltrate it as it is. They have to archive it to reduce the size. So large uploads, especially off hours, you have to look on this finance system, file server, and you have to look where it's going. The destination is going to be unusual domain or IP. So check for file type, data volume, destination, reputation, user behavior, all this stuff. L2 investigation, determine what data left, how much, which user compliance. Web attack, common SOC visibility, we have SQL injection. Again, I'm not going to, okay. These are web attack. Web attacks are actually, you can look for SQL injection, okay, if you have WAF, okay, web, yeah, this and database error, suspicious URL. Actually, this is a command, SQL injection also, I covered before, command injection. The idea is you're going to check the source IP, okay, the system. So the idea of web attack, most web attacks are due to input, okay. So for example, you see, when a web application doesn't have proper input validation or sanitization, basically it causes, like for example, if I put this inside a login form, a normal login form, okay, for in a page that is not properly checking or validating or sanitizing the forms, I'm going to get all the users and passwords from the log there, from the database, right? Especially if it is not, if they're using raw SQL, their code. This command injection, this is just who am I? All this stuff can be also used. Same concept. Web shell attacks, we have very common for interface attacks. Web shells are like file upload. So for example, I'm going to make a script here, .php or something like this. Okay, so I'm going to upload it to the application. Okay, then yeah, cloud attack increase the common, and you have to check the cloud attack as well. Possible travel, see for weird IPs, and MFA, make sure MFA is enabled because new API keys, suspicious app registration. So geo anomaly is basically the location. This L1 will check user agent. Also user agent, you can find out the browser's details and stuff. MFA, change or API activity. So L2 focus, they focus on the persistence, this advanced stuff basically. So the most important real world detection patterns are if you see any office that's spawning PowerShell, for example, or if you see any browser that's spawning CMD, for example, if you see any PowerShell XE makes outbound HTTPS, all this stuff. If you see credential theft, if else has access, that means someone tried to access, try to do credential dumping. If you see multiple failed login plus success, possible spray attack. Okay, multiple failed login and success. And rare admin activity, like especially after hours, unusual host, service accounts, all this. We have fast attack triage. So the first thing you need to do, this is check for success. Okay, check for MFA, geo, persistence. Check for if there is a malware alert, then check for process tree. Okay, check for network persistence, spread. PowerShell alert, check for encoded parent outbound traffic. Ransomware, check for encryption behavior, shadow deletion, tail movement, domain impact. So what a real SOCs escalate fast. They never ignore and move on. If the domain admin is compromised, this is very dangerous, because if I have access to the Active Directory, then I own everything, all the users, the whole network, the whole system, right? And ransomware, if this is like a finance or a banking organization, okay, where that is very important, then if they encrypt my data, it's going to be very risky, affect the business. So this is very important, cannot be ignored. LSAS dumping, again, if they check, if they get access, they can use, they check for PowerShell execution, widespread fail login, active C2 beaconing, data exfiltration, all this stuff, okay, are the key things we need to understand for this is what we need to understand to be a SOC analyst, okay, until now. So I only showed you what again, you have to learn also something about Wireshark here also. Okay, I don't want to go through it again because I already covered it. I don't see a point of covering it again and again. Here I think I have already covered Wireshark. Let me see if I have covered it. Yeah, here I've talked about Wireshark in details, I think. Yeah, we have talked about Wireshark, even advanced concept of Wireshark. I've talked about it here, go through it, and map and everything. So yeah, that's it. Also, I've talked about also try to have a look on the as a SOC analyst. Actually, you are required to know a little bit about firewall and intrusion detection. Again, I don't want to go through it because I already covered firewall also here. I've talked about different types of firewalls here. I mean, I've talked about FortiGate, okay, here on this course, so you can have a look at it. Okay, you will learn a lot from this. And if you finish this, then just have a look at suricata or snort, okay, which is used for logging. And yeah, it's used for network intrusion detection system, IDS and IPS. So the difference between IDS and IDS versus IPS is actually important to know. IPS are security tools that analyze network traffic for malicious activity. The core difference is that IDS is passive, monitoring and alerting, while IPS is active. That's the difference. Okay? IDS acts as a security camera. It just sees, alerts you. That's it. It doesn't stop if there is any attack or anything. It just lets you know. Okay? IPS prevents it. Okay? That's the main difference of IDS and IPS versus SIM. This is important to understand differences actually. We have to know the differences in details. So yeah, we have to know the difference between these three. Okay, IDS by itself doesn't fix problem. It detects, reports to the system administrator have to read. System administrator have to read the report, decide whether it indicates real problem or layout course of action. IPS takes automated actions in response to a detected threat. It can call, close off an IP address, limit access, block an account. SIEM is a replacement for IDS and IPS. Okay, SIEM is something else. SIEM uses the information from IDS, IPS logs, firewall. Okay, we've talked about this also. SIEM just takes the information from IPS and IDS. So I don't know if I have. Yeah, I think I have some. Let me check my VMware here. Okay. Let me see if I can find something about. This is my Ubuntu. To install suricata is actually very simple. Okay, there is a tool here you can install it. Suricata was the easiest to install actually. Install Splunk already. We've talked about it. It's very simple. You just have to go to Splunk. Okay, you're going to use it in Linux. You just have to go to here. I don't need to cover this actually because I already covered it in setting up a SOC with Splunk. You just go to their website, get the wget link or download it directly from their website, and then install this. Use this command to install, then start it using this command. Okay, then it will ask you to put the username and password and enable. Then you can access this one. Okay, so this is the idea. And suricata is also, you can install it using this command, okay, which is already installed on my PC, but you can use this command, sudo apt install -y suricata, and you can check the interface using this command, like I'm using this one. So I'm just going to edit sudo nano etc. Remember this path, etc suricata.yaml. I'm just going to edit the interface where we want suricata to monitor. Okay, replace with your interface. Okay, and then update it. Use this command to update suricata. Then you can use to test the configuration, basically this one, and run the suricata. This is to run the suricata. That's all you need to do. And just you can find the logs here. Okay, this is what we need to do. In my case, let me, because I already did install it, I don't think I have to do it again. I just want to show you how it looks like. This is my Ubuntu. So I'm going to open a terminal here. Let me check first what network I'm using. Okay, I'm using NAT, so it's okay. So I'm just going to run this command. just so it will run suricata. But before that, let me check what is my interface, my IP. Yeah, this is my IP, this is my interface. So what I need to do is just run this command, but I will change this one, ENS. I'll use this command, and sudo suricata dot YAML, okay, YAML, and minus I ENS 033. I think there is no 0, it's ENS 33, and ask me to put the password. Failed to open, no such file or directory. So this must be a mistake with the name, or let's see, suricata. Oh, okay, yeah, I missed one folder, suricata here. So now it's running, but right now actually what I need to do is I'll find the logs here, but I can just Control C, open a new terminal, add a new terminal here. Space is not going to work. Let me see, tail var log and suricata, such file or directory, because okay, I think I need to cut the directory. Okay. Let me go there instead. 1 second, let me check, go through here and see what we have here. Okay, here are the logs stored actually on these 3 folders. So I think I'm going to check suricata log. Suricata dot log. So this is suricata logs. Okay, I think it is doing that, but I think we need to do some extra configuration so we can add rules. We have to add rules to this. Okay, so let us go to suricata rules. Go here. Yeah, we can check the documentation here. But before this, I think we need to go to this one. I believe it's, yeah, this one itself. It might be this one, yeah. Let me go ahead. This YAML file, I think we need to have a look at it. Go to okay, I'm going to do sudo. Okay, sudo. Okay, suricata. Not suricata. I'm just going to do nano actually, and open this file. Let's see, suricata and suricata dot YAML. Yeah, I'm going to put my password. Yes, this is the config file, and okay, there are some configuration that we need to do here. Okay, yeah, but right now for our yeah, so I'm going to go down for the local path. There is a path where we put where we mention where the log is actually uh, where we write the rules. Okay, and we can change the logs also. Let me see here. Rule managements. Adding your own rules. No, sorry, this is adding your own rules here. So this is actually the command. Sudo nano local rules. You can add your rules here. Okay. Update suricata configuration so your rule is included. This is what I just did, and make sure the local rules included is added to the list of rules. So you're supposed to add the local rules here. Okay, local rules. Okay. So I'm going to just control ask here. I'm going to check the rules here. This is important. EF packet. Actually, this is still showing. The interface is showing ETH 0. This has to be changed to ENS33. Okay. And what else we have? Interface default. So if you go to the we find it here. This is the rules. Path, sorry, we need actually the path. Here. Not here, I think it's not here. One second. We need rule path. Yeah, this one. This is the default rule path. Okay, this is the rule file. So you can go ahead and add something here. Okay, type like local rules here. Rules. I think this will work. Local.rules. Here you can put it in the same folder, so that's fine. So yeah, local rules under rule path, rule files, and okay, let me go. Okay, so I'm just going to go ahead and go to the path. Okay, I've changed the rule path already. I want to add local rules. I want to add it here under suricata rules. Let's see. Okay, so I will go to ls here. I will go to cd ls No, I want to do it in suricata. Dot the less. So I will go to cd lib. I think I have to go to lib folder like this, and yeah, I think it's here. cd suricata. Let's. Yeah, no, it's not here because yeah, I think we can find here on the, but I prefer to use Vim, so we can, it will be easy for us to search. Okay, let me just use this one. Yeah, I will use Vim instead of Nano. Command not found vi. Okay, so yeah, one benefit. Let's see. This is vi not Vim, so yeah, it was after this. var lib suricata rules. Okay, let me open another terminal here. Var lib suricata rules. Let me open another terminal. cd var lib suricata ls. Yeah, we have rules here, cd rules. Okay, then ls. So here we don't have local rules, but we can create. So we can just create vim vi local dot rules. Okay, this is a new file. Okay, so we can just click esc and insert. Okay, actually this is stuck, so I'm just going to see ls here. Yeah, so sudo local dot rules. Okay, so this is great. So now before we add the rules, I think we should follow the yeah. So you'll find the log and heap.json and pass.log. You can use this command, and the rule format is going to be like this. Okay, this is interesting because I want to do this actually. I want to try this. but probably I have to add it myself manually. So I'm going to go ahead and do that. Okay, any do not read gossip during work. Content scalar. Okay. Mm. Okay. I'm going to go ahead and type the code here, the alert, the rule here. This rule. Actually, I want to do some rule here so we can test. So I'm going to go ahead. For example, you want to create a rule. Okay, there is a website, Snorpy. Snort rules. There's a free website, Snorpy or something else, something. Rules generator. There is an online generator actually. We call it Snorpy. This one. This helps with the creating the rules. So action that we're going to make it alert. Okay. And so it will alert us. The protocol we want to use TCP because HTTP is TCP, right? So source IP, we're going to put it any. We want alerts from any source IP, any port, okay? And the destination IP also any, again, any port as well, okay? Let me check if this is the right, yeah. CSID and the revision number, okay? So this is this is, but I'm going to follow what she gave us here actually. Any IP. This is the source IP. Source IP. We're saying that alert if anyone, okay, any IP and any source IP and any source port IP, source port number, okay, that is trying to access destination IP, any destination IP and any destination port. Okay, message. This is just a message to alert us, to show us. Content scalar, no case. This is the code. So what we want to do is going to try to write this one. Okay. Okay, let me just try to write it manually here. So this is just good practice for us. Alert HTTP. This is just a protocol. Okay, it can be any other protocol. This is just a source IP number, source port IP. This is the source port number, and this is any year, any destination, going to any source port. This is the message to display to tell us. Do not read gossip, something. Okay. During work. And this is the alerts, and if you want you can add content here. This is just extra actually, I don't think we need to add this one. It's not really required, I think. Yeah, I don't think it's required at all, but you can add it if you want. Okay, so let's make sure to put semicolon after that. But this is important. SID, I will add SID 1, semicolon, revision 1. So this is my rules. Okay. Now what I will do is ask ls, yes, save this one. So ls, now we have local rules. Okay. Now let's go to our previous suricata here. I think before running we are supposed to test. Yeah, before running this one we're supposed to test it. To test it we have to use the command to run suricata to see if your rule is being loaded. Okay, that's the idea of this one. Failed to open message file, I think. Okay, this is the wrong, the one that where I forget the. So this will load your. Rule. If the rule failed to load, suricata will display as much information. So now check the logs are enabled. So by default, the logs you can find it here, fast.logs or eth.json. So we have to found error. Yeah, it's seeing our log. You see, this is the rule, sorry, but there is a mistake. Okay, no terminating colon found. So we know our mistake, so let's fix it. Let's at the end I didn't put any semicolon. That's the mistake. I think there should be semicolon after every after every type. You just add semicolon here. Okay, and save it and enter. So let's go ahead and do it again just to make sure it's actually working. Okay, I think it's okay now because it's not giving me an error. The rules are okay. So now what I should do is just try to access some HTTP traffic, right? Like I'm going to try to test vol web here, PHP. I think it's this one. No, this is HTTP. This is HTTPS traffic. But I will try to copy it. Not this is not actually the one that I need. I want this one. This one is HTTP traffic. Let me just try to see what I get. I think this is HTTP traffic. Okay, login. This is HTTP traffic. I should get this one, but let me open it on another terminal. I'm going to use this command. Tail -f -var -log -suricata -fast -log -suricata -fast.log. Okay, we are getting actually let's see. I think it's catching. See, do not read gossip during work. I think it's catching this one actually. Let's confirm if this is the IP of this page. Okay, we can of this page. Okay, let me go to this one. Let me take this domain. Okay, and ping, just so we can get it get the IP easily. Ping here, ping. Sorry, remove the slash, remove the dot here. Something is showing here, but I'm assuming it's this one, yeah. And this is actually the IP of this PC. No, because there's only one way to test. Because let me try to refresh it, see what happens. Go to any other field. It's creating more and more. So I think it's this one. Okay. Yeah, I think it's this one. Because if you go here, copy this one and try to paste it here. No, if you go to 185.190.100.180. Should open us that file, that page right here, right? So also we can use Wireshark to demonstrate here. Wireshark we have. Let's use our Ethernet here. Yeah, let's go back to our original website here. This is the login, and let me just filter by HTTP here. Yeah, so this is the login that I found. Okay, so yeah, this is the login that we found. So this is what I wanted to show you in Suricata. And in Wireshark, okay, I think we already covered this in my previous, so I don't want to go deep in it. But just a quick overview. This is basically a Wireshark. You can filter by protocols like HTTP. If you want DNS, you can filter by DNS. If you want, let's say, DHCP, you can filter by DHCP based on what traffic you need. Okay, and based on what traffic you need. Okay, and yeah, so HTTP, if you want HTTP, also you can add more detail here. Like you want request method to be post, we need only post data. You can increase this one. Okay, right now we don't have a post method. We don't have a traffic with post. I can create one. Like I can just type here admin username, and I can type here password. Admin123. Let me log in. I just created a post traffic here. Okay, post means when it's sending to the server. Okay, get means when it's getting from the server. Okay, forms are usually a post request. We use the post method, right? We get here, I got here data, and here if you notice also, if I open this or if I just go to here follow HTTP stream or TCP stream, okay, this is what I will get. I will get the details here. I will get both the username, here you can see the username admin, and the password admin123 in clear text. Okay, that's why using HTTP is not secure. It's not recommended because it's not secure, right? So this is the idea that I wanted to show you in Wireshark. Just remember this one. Follow TCP stream to get to go detail in the traffic. And let's say you want to extract an object. You can go here, file, export an object. You can choose what kind of file you want to extract. Okay. And we have statistics also here. These are basically summaries. And yeah, so this is basically it. I don't think there's more. about. And that's all for today, and thank you. I think this is the last video for the course, and I think it's enough. If you want more details, you can read on your own. Wireshark cheat sheets we have here, cheat sheets we have. We can check the cheat sheets here. Yeah, and or this is, you can go here like IP address, IP destination. Again, I've talked about this in detail actually, so I don't have to go ahead and review this. I'm just showing you what you can search for. Yeah, you can filter by protocols just like I showed you, if you know the protocol, or you can filter by IP address like this, IP source, this one, okay, IP destination, this one, IP address, this one, and port filter, TCP.source port, this one. You can try all this stuff using content, for example, payload, send handshake. You can do this one. You can filter with this, and many more here. This is important, possible file transfer. Like if I check this one, for example, TCP length is greater than 1000. If I paste this one here, basically I'm looking for traffic that's sending huge data to the outside. This is one sign that there is some huge data exfiltration. So basically that's one thing. Also this one, jumbo bucket, and this is to detect HTTP post request. I showed you this one. This is to check for SMP traffic. And yeah, advanced Wireshark we have here, Wireshark node. And that's it. I'm going to try to install Zeek. Okay, just so we can have a look at it. So let's check the documentation for Zeek. Zeek docs. Yeah, quick start installing Zeek. Zeek is also important. I don't want to use Docker image, but let's start with Docker image. For Linux, for example, the latest Zeek 8 release on Ubuntu 2.4 step. So you just have to copy this one. It will give you the latest Zeek release. Just copy this one. You can check the documentation. It will always give you the latest information. So all you have to do is go to your Ubuntu and paste this one. Okay, but in this case it's not pasting, so let me go ahead here, edit, paste here. So it's going to install for me. Okay. Okay, once I install it, the next step is going to be what exactly? Running it, right? Quick start, you can check running zeek. And running zeek, yeah, should not produce any output. Will create few logs file. It will give you different logs like con.log, http.log. Con records each connection zeek detects. So we have two options. We can either monitor previously captured pickup files, or we can just capture live network. Okay, let's try to do that. Zeek here minus I ENS 33 dash C. Let's see if ENS 33 sudo apt install zeek. Yes. So I'm just going to install zeek. Check. So I can't do it actually, it seems like. So I have to ignore it. Let's see if it will finish the installation, because I just want to install it and try it if it works. Yeah, just what we need to understand is actually just the benefits, the use of zeek. Okay. What is zeek? Like, zeek is a passive open source network traffic analyzer. Many operator uses it. It's like a network security monitor, okay, to support investigation of suspicious malicious activity. This is the job of zeek. New users derive from zeek's extensive sets of logs describing network activity. This is focused on network activity. These logs include not only comprehensive records of every connection seen on the wire, but also application layer transcripts, requested URIs, keys, headers, all this stuff. Okay, all this information. Okay, so that's why zeek is very important. Log zeek comes with built-in functionality for range of analysis, detection, tasks, all this stuff. You can tune it, you can do a lot of things with it. This is just click OK here. Okay, fine. No configuration, should choose okay. General main configuration, no configuration for now. Okay. Okay, let's see. Let's wait for it to finish. I don't think it's actually working. No, it's working. There's one thing to need. So what we need to know is like zeek versus Wireshark. You will understand the difference. Then everything else will be easy for you. No configuration. So I'm not okay. The difference that we need to focus on is like zeek is a network security monitoring platform that generates high-level, structured logs for behavior analysis and incident response. Wireshark is packet level analyzer, designed for in-depth interactive forensic role management. So Zeek will give you organized logs like HTTP, DNS connection. Wireshark shows raw packet data. Detecting anomalies. So if you're investigating a specific incident, just use Wireshark. But if you are using for long-term monitoring and detecting, use Zeek. Okay. Zeek output is text-based. Okay, packet. Okay. Zeek logs are often sent to SIEM for analysis. For analysis. There you go. So both are used by SOC analysts. I just want to mention it. Okay. And you can install it on your own PC and check it because, yeah. And that's about it. And I think we've talked about malware analysis before. We have two types: static and dynamic analysis. Dynamic analysis, basically, I've showed you already. Running the malware and checking if checking the malware activity while after running it. You can't obviously cannot open the malware on your PC. You have to use a sandbox environment like any run here. It's a very good way where you can run your malware. Okay, you can use VirusTotal also to check whether it's malicious or no. And static analysis, usually there are indicators how you can know using static analysis. Static analysis, malware indicators, indicator of file. So examine so obviously we are going to check it using VirusTotal. This is the first thing we are going to do, right? Any malware, okay, and yeah, and before that, yeah, you will get the cryptographic hash. I showed you how to get it in the phishing video. And also, if you know this file extension mismatch like this, for example, executable or suspicious timestamp like in the future, or all zeros 1970, something dates like this, and string or embedded data, like using string analysis. Okay, there are tools for this actually. One second, I want to check malware string analysis tool. This is it. This is a good one. Strings. It's from sysinternal. Okay, I'm going to download it. Okay, and try to show you how we can identify malware. Let me download strings. Okay, you can. It will. Yeah. Extract it to, let's say, desktop or downloads. Okay, I will open downloads here. Extract all. CMD. I think we're supposed to run it this way. String. And you put the file name or the path, something like that. I'm not sure about it. Let me try it. Yeah, I used it before, but once again, yeah, this is the command. You're supposed to use type strings here, okay, and okay, you're supposed to type strings and but there is better tools, I think, instead of okay, basically you're going to get an idea, just so we get an idea of what we are doing actually. When we say string analysis, okay, text to search for okay, yeah. Mm, yeah, so this is the tools that we talked about. Yeah, basically what we will focus on is basically we're going to search for IP addresses. I think PS Studio will do this for you. I think PS okay, so yeah, we'll check for hard-coded IP addresses, domains, URLs. Okay, that's when we say string analysis, that's what we mean. It's just going to, this tool is going to give you in a notepad all the strings that's available in the malware. Okay, so it's going to be structured or ordered. It's going to be a mess. Okay, so you have to filter, check for IP addresses, check for domains, URLs. Okay, weird domains, or paths or API functions like create, remove thread, or this stuff. PE header also, check for this. High entropy also, we talked about this. If it's entropy is higher, it's bad. And this is actually a good tool, PE Studio. I have it on my PC. This is going to show us a lot. Just run this tool. Yeah, so let's drop a malware, not a malware, just I want to drop any file here, okay, and show you what it is. So here, this is the string. Okay, if you go to strings here, you can see all the files here, all the values available on this file. Okay, you can look, this is what the string analysis is. It gives you all the values available. Okay, so here is the virus total scan. Gives you, it's telling you not, this file is safe. Okay, this PE Studio is a great tool for malware analysis because it has a lot of features. Footprint indicator, you have the file name here, SHA, and scan, all these details. Okay, so this is just one example. Also, we have to make sure we can check HXD tool. And die tool is also, I want to try this one. Flows. Yeah, I want to try this tool. Okay, I want to try this tool. And HXD also, I want to try it. Yeah, let's download this one. Detected easy tool, and download text editor also, because this also will give us some information, just to familiarize ourselves with the common tools that is used for malware analysis. Close it and run this one. I accept. So this is a hex editor, so let me go ahead and open a file here. This time I'm going to choose icar here. It's supposed to be a fake malware file. Okay, it's not malware, it's just it's fake. Okay, so it's going to give you all this. Okay, this is a standard antivirus test file. Okay, and let's try the other one. Detected easy. Okay, it was deleted actually. It's not secure. So, but it's okay. So this is what I wanted to cover. But you've got the point. Okay. So I think this is enough for SOC Analyst L1 L2. We covered the basics and advanced also. And thank you for watching.